Well, continuing with our discussion on section 3.2, now that we're introduced to the function notation, let's find out what kind of tricks we can do. I know it's math tricks, but well, we can do some different things here. For example, let's say we're told we have the function p of t is 4 times t minus 7. So the rule p says that whatever value we have for t, multiply it by 4 and subtract 7. If it helps, you can think of this as a fill in the blank, right? So whatever we have in place of t, we would multiply it by 4 and then subtract 7 from the result. So we've said, for example, right now, if I told you I had 2 in place of t, you would take 4 times 2 and subtract 7. And you know that's going to give us 8 minus 7, or 1. Well, that's an easy one, right? Because we're just replacing it. But what do we say this? P of s plus 1, what's that supposed to mean? Well, if we use this notation then, that p of whatever value it goes in the parentheses is 4 times whatever we put in the parentheses minus 7, and we substitute in the value s plus 1, well, that means we come up with a new expression, 4 times the quantity s plus 1 minus 7. So if we work this out, we would have to distribute our 4 into the parentheses to eliminate the parentheses by the order of operations. 4 times x plus 4 times 1 minus 7. But if we simplify that one more time, p of s plus 1 is the same thing as saying 4 times s minus 3. So we come up with a brand new function altogether. Kind of cool to realize that you can do this. It's a cool trick. Well, how about this one? Let's find the range of the function if we give a specified domain of -4, -3, -2, -1, and 0. What does that mean? Well, essentially, all we're really doing is that our domain is the set of all first coordinates, right? We defined that at first. Well, all the first coordinates are the set of all values of x. So we're saying, let's let x equal -4. Let's let x equal -3. And so on down the list, and let's find out what the values of y are that go with these. If we get these values for our domain, we're going to substitute them in one by one. And let's just figure out what happens. So I'll work it out here. I'll give you the first one. Let's say I find f of -4. Well, of course, like we said before, this is where we substitute in -4 anywhere we see x. So we're going to take -4, and we're going to square that value. We're going to add to it 4 times -4. And then we're going to subtract 1 from that. While we do that, looks like we're going to get 16 minus 16 minus 1, or in other words, -1. So the first value in our range, we'll put it over here, our first value in our range will be -1, it looks like. Let's see what else is in our range right here. We have to find f of -3. Okay? So I'll let you work these out. Take a moment right here, pause the video, work them out on your paper as an exercise, and we'll come back in just a second and check. Okay, did you work them out? Here they are. These are my values. I got -1, -4, -5, -4, and then -1. So if we set up our range in order from smallest to largest, our range consists of the numbers -5, -4, and -1. And that's it. That's our entire range. So we can get a domain and find the range, which is essentially just the y values from each of our points. All right, one last trick. Let's try this one. It says f of x equals 2x plus 5. So our rule f says take x, multiply it by 2, add 5. It says find a number c in the domain of f such that f of c equals -1, and write the corresponding ordered pair of the function. Now I know this seems like a really complex kind of thing that's going on, but in fact it's really, really simple. Remember above in our first trick we said that, well, anything that we put inside of the parentheses is how we're going to evaluate x. So we can put anything in the parentheses. It doesn't have to be x. We could say, well, f of c would be 2 times c plus 5 instead of c instead of x, right, in place of x. So what else did we say? Well, in this problem, it's telling you, well, let's find where f of c is equal to -1. We have a principle that says if we tell you that f of c is equal to 2c plus 5 and f of c is equal to -1, well, let's skip the middleman right here, right? What purpose do we need for the f of c if we could say that, well, 2c plus 5 and -1 both equal f of c, therefore 2c plus 5 must equal -1 itself, which means that in order to find the value of c in the domain such that f of c is equal to -1, we solve for c. All right, so we just need to do a little bit of algebra right here now. So we subtract 5 from both sides of our equation. When we do that, we get 2 times c is equal to -6. Of course, we divide both sides by 2, and we find that c is equal to -3. What does that mean? Well, what we've just found is the value of x that we would have to substitute into this function to get -1, right? We can check that, right? F of -3 equals 2 times -3 plus 5, which is equal to -6 plus 5. Oh, sorry about that. Make sure my plus looks like a plus there. Plus 5, which is in fact -1, just like we predicted. What's the ordered pair right here? Well, this is saying that when x is equal to -3, y is equal to -1, and our ordered pair then will be the values -3 in place of x, -1 in place of y. More in the next video.